Okay, so here we're going to look at the first application of integration problem for the reciprocal, which is an area under the curve. Now part A is actually requesting us to sketch the area bounded by y equals 1, x equals 8 in the curve y equals 4 on x. Now, even if it didn't ask us to do that, I'd recommend if we didn't have a graph, we would need to start off with that anyway, because we need to clearly see where our region is that we're being asked to calculate the area of. So I'll just set up some axes. Okay, now it's important that we have some context around what this curve is going to look like, but also we've got two lines. We've got y equals 1, which is going to be a horizontal line that will look something like that, going through the point where y is 1. We've also got the point x equals 8, which will be a vertical line going through where the x-axis is 8. But we need to really just get a gauge on where these intersect with the curve y equals 4 on x. So if we've got the function y equals 4 on x, when y is equal to 1, so when y is equal to 1, we end up with 1 equals 4 on x. If we rearrange that, we end up with x equals 4 on 1, so therefore x equals 4. So we know that they intersect at the point 4, 1. We also then can look at, well, what happens when x equals 8? Well, y is equal to 4 over 8, so y is equal to a half. So therefore they intersect at the point 8, 1 half. So we've got 2 points of intersection there that we can mark on, just to give us a little bit of scale around what we're working with. And again, the scale's not really important. What we're more interested in here is just how this sets up. So we can put 4 there, we can put 8 there. If I put 1 on the axis, therefore a half's going to be there, so that's going to intersect through like that. And then we'll draw our curve in like so. Now, if we draw in our lines that we've been given, so y equals 1, that's horizontal going through like so. And then our other line is x equals 8, so we'll draw x equals 8 in. And this is, so it says sketch the area bounded by the coordinate axis. So the coordinate axis is the x and y axis, the line y equals 1 and the line x equals 8. So if we were just to, one of the ways really you can look at this is you can actually draw all those in. It gives you quite clear boundaries of what we're working with. So the coordinate axis, so that's x, so y and x-axis, the line y equals 1, the line x equals 8, and the curve y equals 4 on x. And you can clearly see there's a region there that's bounded by, it has to be bounded by all of those things, and that would be this region here. Now, interestingly, to calculate this area, we actually need to look at dividing this up into 2 parts, because you might be able to see this first part of the area here, which we'll call A1, is just a rectangle, and this area here is actually the area under the curve. So we need to split this into 2 parts. Now, part B then says determine this area of the region with the aid of an appropriate integral. So we can say, well, the area is equal to A1 plus A2. Now, A1 is just a rectangle. It's got a height of 1, a length of 4 and a width of 1. So 1 times 4, plus the area of A2. Now, the area of A2 is the integral between 4 and 8 of our function, which is 4 on x dx. So if we carry this through, we've got 4 plus integral, well, 4 on x integrates to 4 ln x between 8 and 4, which is 4 plus 4 ln 8 minus 4 ln 4. Now, we can take 4 out as a common factor, so we end up with 4 lots of 1 plus ln 8 minus ln 4, and using the log laws, we can simplify ln 8 minus ln 4 to be ln 2. And how we just did that just as a recap, remember the rule that if you've got ln of A minus ln of B, that is the same as ln of A on B. So what we've done there, that's ln 8 minus ln 4, so that's the same as ln 8 over 4, which is the same as ln 2. And just one last thing we need to leave in there is unit squared, because it is area. So that's a good little question in terms of a sketch, thinking about how the area is broken down, finding some points of intersection as well to help give us a clear diagram and a clear area that's bounded, and then from there we can then calculate the area.